Hello, eighth graders. Today we're going to go over chapter 2, which is about mineral identification. I know that we've been working on this already in class, and I know that you distance learners have learned a bit about this too on some online web quests and slideshows, but I want to get into a little bit more detail. We start out with this beautiful mineral here, and it asks, how could you identify this? Well, scientists don't just memorize everything that they see. You know, if a mineralogist is studying rocks and minerals, they don't just know everything just by sight. Just like an entomologist isn't going to memorize every species of insect out there, or a botanist is not going to memorize every kind of plant. We have tools that that will help us narrow down the possibilities of something's identity based on their physical characteristics. Okay, so we use a mineral identification chart in order to identify our minerals here in class. We do use things like color and shape, whether it's shiny or dull, if there's lines running across the mineral like this one does. Those are all physical characteristics that are important to identifying what type of mineral we are talking about. The most common field techniques put the observer in the shoes of a detective, whose goal is to determine by process of elimination what the mineral in question is. The process of elimination usually includes observing things like color, hardness, smell, solubility in an acid, streak, striations, and or cleavage. And those are all things that we've talked about in class. Okay, the first one is color. Now we talked about how color is it's a useful characteristic, but it cannot be used alone because, for instance, quartz comes in every color of the rainbow. And sometimes a mineral, if it is exposed to other minerals or water or sunlight, they can actually affect their outward color. So color should only ever be used along with some other physical characteristics. Streak, however, is much more reliable. This specimen of quartz, I could have 10 different colors of quartz, but they will all give the same streak. Remember, streak is the powdered form of a mineral. So I'm going to take this sample of hematite here. I drag it across a streak plate, and I get a reddish streak on this white streak plate. If I had a different color sample of hematite, they're all going to give the same streak. Okay, so streak is a really handy characteristic. Luster is another one. In class, we have been determining first whether or not a mineral is metallic or metal-like or not metallic. If it's not metallic, then it has all of these other possibilities. Some, like quartz could be a little bit glassy. Some other ones could be earthy or pearly, looks kind of like a pearl. There's all kinds of different lusters in addition to the metallic lusters. So like this is a piece of chalcopyrite. It's metallic. This is a piece of hematite. It's got a little bit of rust kind of color on it. Both of these have a metallic luster. Both of these have a non-metallic luster. The density of a mineral also is a good identifier. Some minerals per cubic centimeter are heavier than others. So if I have two minerals of the same size sitting in my hand and one feels a lot heavier, its molecules are more densely packed. And so there are some that are really particularly light. They almost feel like a bar of soap. They're so light. And then there are some that's like, oof, it's like lead. Lead is one of the minerals that we identify. So some of them are just comparatively One will be a lot more dense than another. Hardness is the thing that we have talked the most about. The hardness scale goes from 1 to actually 10. An example of a 10 would be diamond. Remember that these minerals right here are not the only minerals that categorize at these numbers. These are just examples of some that do. Okay, so maybe you have a known, like I have a piece of quartz right here. I know this is quartz. I know that quartz is a 7. And I have an unknown mineral right here, and I want to find out which one is harder. I can scratch these two together, and because I know this one is a 7, and I'm seeing that quartz is actually scratching this other one, I know that this one is softer than a 7. Okay, so you can use known minerals, and you don't have to go through the entire process of starting with your fingernail and then scratching with a penny and then scratching on glass and then a steel nail. Cleavage and fracture is another defining characteristic. I'm going to just grab a sample of halite because it's a really good example. Hang on a second here. Okay. So halite is rock salt, and it comes off in cubes. See how perfectly cubical that is? So if I smash this with a hammer, you are going to see it break apart in sheets and blocks, just like this. Same thing is true with calcite. It's another one. You can see that there is a flat surface here that light shines back on all at the same time. I don't know if you can kind of see the light reflecting back off of this all at the same time or at the same angle. That's cleavage. This does not have that. This just breaks off in random chunks. Same thing with quartz. Quartz is shiny, but it does not have those flat surfaces. So don't confuse shininess with cleavage. Same thing with this one. This one has just random chunks broken off, whereas these break off in nice flat lines. Okay, that's the difference between cleavage and fracture. There's a few other characteristics that I will show you in just a second. A couple other unique characteristics. Fluorite is a really cool mineral that will actually glow underneath fluorescent or ultraviolet light. We don't have the tools to make that happen, but you can look online and find some really cool pictures of fluorite underneath ultraviolet light. Magnetite is a mineral that is a magnet will stick to. So that is one thing, like there's a couple other minerals that are much like magnetite and they have similar other characteristics, hardness and density and their streak. But the only thing that you can do to really define that this is magnetite is use a magnet to see if it sticks. Sulfur has a very distinct smell. It smells like matches or rotten eggs. I think it smells like matches. Halite has a very specific taste. This is rock salt, so if I were to lick it, which we are not going to do in class, it would taste very, very salty. So if you're out in nature and you think you found rock salt, that would be something you could do, but not in a classroom. Another cool one is calcite will actually bubble when it's exposed to a weak acid. So I'll show you that. I don't know if you'll be able to see this or not, but let's give it a shot. Okay, so I put my mineral right here. I've got some very weak acid right here, and you should see a little fizz. Let's see if it works. Can you hear that fizzing? It's fizzing. Okay, so there's a couple minerals that have a lot of the same characteristics, and the one thing that you would do to distinguish between the two is pour a little bit of weak acid on top of them. All right, there are a few questions here, 5 questions that go right along with this video. All right, so you're going to access this. You're going to access the iBook right in Google Classroom. I'll show you where that is again. Okay, so it's under Coda's Geology iBook under Materials. You'll go to Chapter 2. You're going to go to the end of Chapter 2 where we just were. Right, here's Chapter 2. We talked about all this, and there's a little video here. You're going to watch this video link and answer these questions on the...
Rachel Steinke and Isabel Butterfield, please report to the office.
Sorry. There's the Geology iBook answer sheet. Okay, so you'll see that under Chapter 2, there's a space for 5 answers to your questions. All right, so you should now have Chapter 1 done, and now Chapter 2. And we will move on to rocks later on, actually probably next week. We are going to do a few more things with minerals this week, and then we'll start fresh with rocks on next Monday. I hope you're well. Talk to you soon.